So we talk about the maximum and minimum values, right? Last time. So again, quickly recalling it, if the functions in the entire domain, most of the time we was talking about in a closed interval methods, right? So in a closed interval or the entire domains, um, if one of the function value is the highest, the largest among the others in that particular domains, then we call that absolute maximum. And if the one of the function value is the smallest, right, value on this interval of the domain, then we call it as absolute minimum. And those values are called the extreme values of the function. Okay. Then the next thing is the difference is this part, the local max and local minimum that we mentioned last time on the definitions. I want to emphasize this again. Local max and local minimum is talking about only on the open interval. I want to highlight that, okay? Because the local max and local minimum cannot happen on the endpoint. It cannot happen on the endpoint. So local max and local minimums are, happening on the open interval such that, when close to, not the entire domain, when it's close to, that particular C value in the interval, open interval, that f of C is the highest amount in this interval. Right? Not in the entire intervals, okay? Close to that. And these will be considered as local minimum on an open interval around that number C. Because if you move away from this, then it may be like some value that is like smaller than that. So that would be another local minimum that we are talking about, right? Like for example, this value right here, and it is also what equal to this value. So it cannot happen. So it will be open interval around that. Okay. And what we are interested in is like, how to find those C values, right? And we define those number as a new name, which is called the critical numbers. Okay, so when the critical numbers, when is the critical numbers going to happen? The critical numbers are basically when f prime of a particular number C is equal to 0, because you can see that if it's a local max or local minimum, it's a peak, and at those peak, the tangent, the slope of the tangent line is 0. So that's where this idea coming from, f prime of C is equal to 0. Okay? But however, also if you look at on this case, that is basically what f prime does not exist. So we cannot just leave it with f prime of C is equal to 0. We need to also talk about what f prime of C is equal to D and E does not exist. Right? And those C values are called the critical numbers. So that's what we talked about yesterday, last class meeting. Right? So I'm just recalling it so that we can continue with this definitions. And there are a couple theorems that we mentioned also, right? And those are not really important theorem, but it will sort of give you a glance of what we're talking about. So one theorem that we talk about is extreme value theorems, which is if it is like, a function is continuous on a closed interval, that's all, the condition. Once you know that in a closed interval the function is continuous, then the extreme value theorems guarantee that you will get absolute maximum and absolute minimum in that interval. Okay. So what we want to look at is like the first problem. The first example is basically, looking at this right here, sketching the functions, right, f that is continuous on a closed interval from 1 to 5, and having all of this condition, absolute minimum at 1, absolute maximum at 5, local minimum at 4, and then local maximum at 2. So basically, what's happening is, I can only sketch one of the family of the graph that's satisfying these conditions. So first, my interval will be from 1 to 5. And then I will have the absolute minimum at 1. So this is the point that I marked right here. But I don't really know that, the actual function has absolute minimum at that point. I'm just talking, that's why I'm saying that we are just graphing one of the family of the graph, sketching one of the family of the graph, which will give us, the situations. And another point that I, put it down is absolute maximum at 5. So I'll put it 5. Right? And once again, that's just putting in there. Right? It never gives you like exactly what is absolute maximum value is. And then the next thing is a local minimum at 4. So at x is equal to 4, it's local minimum. So you cannot put local minimum is down there because local minimum value, right? The function value of local minimum cannot be smaller than absolute minimum. So you can put in any other place, right, between this value right here, -3 and 5. Right? But however, it's not equal to those. So here's my local minimum. That's where I put it down. And then at 2, that will be local maximum. So once again, this local maximum cannot be, exceed the value of local absolute maximum. So I'm putting down right here. And after that, it will be just like, sketching the graph out of it. And make sure those are peak. Okay. Curve right here. So it has a peak right there. So make sure you draw any questions on this before we move on. All right. So the next thing that we're going to be looking at is like, how to find out the critical numbers, right? Because remember that critical number, the important thing is what? Critical number is what? The value of C when that help you to get f prime of C is equal to 0 or f prime of C is not defined, right? Does not exist. So on the first example, right, on this one, it's given to you a polynomial functions with third degree. And first thing that I need to know is this functions, differentiable or not, right? Because only we need to know where is it differentiable and where it's not differentiable, so that I can talk about like, f prime of C is equal to 0 or f prime of C is not defined. So we need to consider that, right? So you need to keep in mind with this, right? Keep in mind on this one. That's the definitions of a critical number. That's how we're going to get the critical number C's. So first, what I need to do is I need to find out, what is the domain of the functions. That is a must. Okay, starting from now, you need to double check on the prompts. So in this case, this is a polynomial, so the domain is all real number. So that basically, also tell us from the past, f is differentiable everywhere. So that tells us for this particular, functions, I will not get these situations at all. Okay, I will not get these situations at all. So, so therefore, after I take the derivatives f prime, which is going to be 3x squared plus 12x minus 15, then my critical numbers for this particular problem, my critical numbers only will happen when f prime of C is equal to 0. Right? So we are already like, considering this will not happen for this particular case. So now, setting f prime of x equal to 0, that will allow me to solve that equations for those x value that you need, which is the critical number. So 3x squared plus 12x plus 15 equals 0. Divide everything by 3. And after that, I factor it out. So once I got the factor, then I can clearly see that x equal to -5 and x equal to 1, those are what? The possible critical number. Okay? Possible critical numbers. Now, why do I say possible critical numbers? Because not necessarily all the time on each questions, I will ask you to look into on the entire domain. Sometimes I will give you an interval such that, right, that interval may not include one of these critical numbers. Are we all clear on this, what I'm talking about? We good? All right. Make sure you stop me, right? As usual in the class. You know, I'm not recording this lecture. I already recorded in the morning, so I have more, you know, I have a better way of teaching. So now that since these two values are like, you know, in the domain of the functions that we are looking for, the local max and local minimum later on. So now I can say that, you know, the critical numbers will be what? Both of the numbers. Are we good? Any questions? Okay. Continuing this. So once again, you know, we don't need to consider this anymore because of what? The particular function that we have. So continue now on to the next example. G of x is equal to x minus 1 over x squared plus 4. So this time we are talking about a rational function. But looking at these functions, you know, since the denominator is x squared plus 4, any number squared is a positive number, plus with not a positive number will never give you 0. So that basically means the function g is defined everywhere. So that's why I put it down, you know, our domain is already a number right here. So now to talk about the critical number, I need to find out my first derivatives, right? Because critical number exists on what? F prime of c equal to 0 or f prime of c does not define, right? Does not exist. So when I take derivatives, this is basically using the quotient rule, derivative of the numerator, right here, right, times the denominator, and then numerator times derivative of denominator, and denominator squared. And when you distribute it and then simplify it, that basically gives me what? Negative x squared plus 2x plus 4 over x squared plus 4 quantity squared. So for these situations, you know, I need to, again, be careful and then look at it. Since the denominator, okay, of the g prime is x squared plus 4 quantity squared, again, none of the x value will make this g prime functions undefined. So that basically means that, you know, this case is out also for the critical number, because we will never get f prime of c is undefined, right? Does not exist. So to think about how to find out the critical numbers, we are only left with what? Thinking about g prime of c is equal to 0. So setting this derivative functions equal to 0 and then solving for it, I multiply both sides by LCD to get rid of the denominator, so I will get this negative x squared plus 2x plus 4 equal to 0. Any questions before I move on from here? So this is not factorable problem. So therefore, what I do is like, I basically use a quadratic formula to find out the solutions of this equation, and which give me, after you reducing everything, 1 plus square root of 5 and 1 minus square root of 5. Once again, both of these will be considered as a critical number for this particular problem because I did not tell you we want to find out in which specific interval, right? I never tells you in which specific interval we want to find this critical number. So therefore, I'm looking at what in this entire domain R. So both of these values included in this entire domain of the original function. So therefore, my critical numbers are both 1 minus square root of 5 and 1 plus square root of 5. So the points right here I'm making is, once again, at this point, because we are not told to look at only in a certain interval, we are looking at what in the entire. So you always need to go back and check with your domain of the original functions. And after all, what we are talking about is like these critical numbers are the peak of the original graph, right? All the way the peak of the original graphs, right? The peak or like some kind of like sharp corners like this of the original curve. Okay, so that's why you always need to know your domain of original functions. So continuing this, the next one is like something that we always like, our favorite trigonometric functions. So the given function is h, which is h of x is equal to 4x minus tangent x. Okay. So while I'm away, did you figure out why my domain is x cannot be equal to pi over 2 plus pi n?
Because tangent.
Yeah, that's true. Remember that the tangent has what? 1 periods on what? Pi over 2 to negative pi over 2, right? Because tangent graph is like this. So, and at this is a pi periods. So another pi period, the tangent will have another asymptotes. So, that's how I pointed out that my domain on this function is everything except what? X cannot be equal to pi over 2 plus pi n, not 2 pi n, because tangent only have pi periods. That's from our trig and then pre-calc, right? So you need to know this, right? Like I said, you need to be able to find out the domain of any type of function because at this point, it's very crucial for us to go back and check all the time, okay? So now we know that our domain of the original functions, then continuing, right? To find out the critical number, I take the derivatives, which is going to be derivative of 4x is 4, derivative of tangent is secant square x. And also right away, I need to know what is the domain of this functions going to be, the derivative functions. The reason why is because we need to think about the critical numbers as the derivative of the functions at some point c equal to 0, or the derivative does not exist. Right? So in this case, the derivatives functions will not exist. Right? Derivative will not exist on what? Those pi over 2 plus pi n, which happen to be all of these values happen to be what? Not a part of the original domain, right? So that's what we find out. So now, looking at the first part of it, which is setting up the derivative function equal to 0 and then solving it. So when I solve for this secant square is equal to 4, it will give me what? Secant x is equal to plus or minus 2. So I have two cases to look at it. Okay. And the first case, secant x is equal to negative 2. And it will be better and easier if you change it into cosine so that it will give you the value a lot faster. So secant is basically 1 over cosine x, right? Is equal to negative 2. So when I reciprocate this left-hand side, that will give me cosine. So if I reciprocate the left-hand side, I also need to reciprocate the right-hand side. That's how I got cosine x is equal to negative 1/2. Okay. So from here, now I'm going to have to find out what the measurements of angles, right, of cosine will give me negative half. That's where you go back to your trigonometry, right, and then looking at this. So these part, I don't have space, so I erased it already. So you might want to recall, hopefully. Quadrantal picture, cosine is a negative on quadrant 2. So this will be what? Negative 1, 2, radical 3. That tells me this angle is what? 60 degrees. And also cosine is negative on quadrant 3. Right? Negative 1, radical 2, negative radical 2, and then 3. And this is also 60 degrees. So this 60 degree is basically what? From here to here that we're talking about. So that will be giving you 2 pi over 3. And this 60 degree is like one more 60 degree than pi, so it'll be what? 4 pi over 3. And you want to make it in general. The reason why is because the original function never tells you, right, your critical number should be in between which interval. So I make it in general such that I added what? 2 pi n for each values. So that'll give me my general solutions. So it will be like over 1 period. Are we all okay so far? Any questions? Okay. Then moving to the second case, same thing. When secant is what? Positive 2. So secant x is equal to 2, that's basically the same thing as saying cosine x is equal to 1/2. So when cosine is a positive value, so that basically what will be in quadrant 1 or in quadrant 4. Because that will be 1, 2, radical 3, and 1, 2, negative radical 3. So this will be 60 degree, and this will be also 60 degree, the reference angle, but it will be what? Away from 360. So therefore, my first answer right here will be pi over 3, 60 degree, and plus what? 2 pi n to generalize it. And this basically 60 degree, this part right here is, right? This part right here is 60 degree away from 2 pi, so it'll be what? 5 pi over 3, and plus pi n channel. So from this, h prime of x equal to 0, we have 4 different critical number, and then from there on, I can generalize it to what? Get infinitely many. Because we all know that tangent, sine, cosine, trigonometry functions are like oscillation functions. So we will definitely get like infinitely many peak. Okay. We good so far? Now another thing that I need to left out and think about is when what? H prime of x does not define. Right? And so I already pointed out earlier, after I take the derivatives of the original h function, right, original function, then I already found out the domain of this, the derivative functions. The domain of derivative function basically say that the function will be, not the derivative does not exist on those what? Pi over 2 plus pi n. So those are my possible critical number. But however, what I need to do is I need to check those value with the domain of the original function. And since those are exactly the same, see that? That's why I put a notes right here. This x value, these x value, pi over 2 plus 2 pi n's are not the domain of original function h. So therefore, these cannot be your critical number. Right? So therefore, these are not critical number. So that ended up with what? Only the 4 critical number that we found out in the first place. Any questions before I move on from here?
Can you just say one more time why the top pi over 2 can't be plus pi n, can't be incoming?
Yeah, so the critical numbers happens on what? When the derivative function is equal to 0, right? Which is like talking about horizontal tangent lines. Or the derivative functions what? Does not define, does not exist. Meaning what? The sharp corner, you don't have any like tangent line at all. You have infinitely many tangent line. Okay? So derivative functions like does not exist. That basically means what? These functions have no, somewhere this function will not define at all,
Mhm.
right? And we already found out that this function's derivative function will not be defined at what? Pi over 2 plus pi n.
Yeah.
Got it, right? Because secant is basically 1 over cosine, right? Cosine was 0 on pi and then pi over n.
Yeah.
So yes, we found out that the derivative function will be does not exist, right? It will not, derivative will not, does not, derivative of the function will not exist on these values. So that means what? Those are possible critical number. But what I need to check is, I need to check, are these values in the domain of original function or not?
Mhm.
Do you see what I'm saying? The
Yeah.
reason why is because the critical numbers are what? The peak of the original functions or the sharp corner of the original functions, right?
Mhm.
So if the original function does not even define on those points, let's say right here, and then vertical asymptotes, right? Evaluate these value into the original function.
Oh, okay. I see what
Do you
you're
see what I'm saying?
Yeah.
So that's why you really need to check, right? Where even though you find this out already, right? The critical number. These are the possible critical number. You need to check, does it inside the domain of the original function that we want or not? Because when you are graphing what? The original functions,
Mhm.
right? Does that make sense?
Yeah.
So therefore now, since this is not in the domain of original functions, then what? We say that the critical numbers are only the first four that we found out. Any other questions? All right. So here's the next example. So this example, notice that I boxed it right here. This time, we want to find the critical numbers of this functions, k function, k of x is equal to cosine 4x plus 2 sine 2x, in the domain of what? 0 to pi only. So we are basically talking about what? In a specific interval, right? In a specific intervals of domain. I want you to mix it up with the bottom part, so let me cut it up right here. So now what's going to happen is, if you look at this, right, we take the derivative of cosine, this k functions. So you need to use the chain rule. Derivative of cosine is negative sine, and the derivative of inner function, which is 4x, will give me 4. And 2 times derivative of sine is cosine, and then derivative of inner function 2x, which will give me 2. Simplifying a little bit, that gives me negative 4x sine 4x, right? Negative 4 times sine 4x plus 4 times cosine 2x. So when this kind of situation is a little bit easier because the original functions already tells you a specific range of domain that you a specific intervals of domain that we want to find out, right? Critical number for. So I don't really need to figure out what is my domain is. But we still need to check what on the domain of this functions, right? K prime, the derivative functions. Since this is a cosine and sine functions, right? The domain of this will be all be a number. So in this case, that basically tells me I will never have these situations. K prime of x is equal to what? T and E. Right? I will never have these situations at all. So therefore, when I think about the critical number, I only need to focus on what the critical numbers are. K prime of C equal to 0. Only the peak part. So I set it up the derivative functions equal to 0 so that I can find out what is my value is going to be, x value is going to be. so that we can talk about an original function. So setting up the equations with the derivative function equal to 0 and divide both sides by -4, that gives me sine 4x minus cosine 2x. And this is where it comes down to, like, do you really need to, are you really strong on your solving trigonometry equation part, right? So that's why I, talk about a lot in my pre-calc class and then trigonometry class, that you need to be, like, really doing well on, trig part, because you're going to see a lot, not only in this, in Calc 2 as well. So sine 4x, you need to be able to see that as, like, the double angle formula. So sine of 2 times, right? Sine 4x as sine of 2 times 2x. So this will be what? Double angle formula for the sine. So that's how I can get 2 sine 2x cosine 2x. Okay? Using the identity. So from here, that's how I move from sine 4x to become this 2 sine 2x cosine 2x. And that allows me to see that I can factor out cosine 2x. Okay with this so far? So finally, solving this cosine 2x, you need to remember how to solve this. Okay? Even though it's talked about in a certain interval of the original functions, the domain is only in a certain interval. When we solve it, we still need to put it into a general format, general solution, so that I can find out for a specific interval. So by saying that cosine is 0 on what? When it's pi over 2, or 3 pi over 2, or 5 pi over 2, and so on and so forth, which is what? Pi over 2 plus pi n. That's the general formula. And we are interested in talking about the value of x, not 2x. So we don't want the double angle. We want a single angle alone by itself. So I divided everything by 2 to this general equations right here. So that gives me x is equal to pi over 4 plus what? Pi n over 2. And remember that this n is the integers, right? From 0, 1, 2, 3, negative 1, 2, 3, so on and so forth. So now, looking at my answers, right? Because I don't need a general solution anymore. I need a specific interval within this interval. So when n is equal to 0, I will be getting what? Pi over 4, right? Because this portion will be 0. When n is equal to 1, then this will become what? Pi over 4 plus pi over 2, which will give me 3 pi over 4. Follow? And then when we look at n is 2, then this will become what? Pi over 4 plus pi, which is basically talking about this part is 5 pi over 4. And 5 pi over 4 is already what? Outside of the 0 to pi interval. So therefore, this cannot be your what? Solution. That's why I crossed it out. So we only have what? 2 solutions from this first case. So you always need to keep in mind with like checking with the domain of original functions right here. Okay? Any questions before I move any further? Do we all understand this? Yes.
Yeah, why is it 2x equals pi over 2 plus pi n? Wouldn't it be 2x equals 2 pi plus pi n?
Okay, so cosine of theta is equal to 0. What is my theta is going to be?
90 degrees.
It's 90 degree, right? Or what? 270 degree,
Oh, okay.
right? But look at 90 degree and 270 degree. That is only what? Pi unit apart.
Mhm.
Agree? So therefore, I
Yeah.
put it down what? Instead of 2 pi, right? Instead of I'm writing like this, pi over 2 plus 2 pi n, and then 3 pi over 2 plus 2 pi n, generalizing like this, I can combine these two and then what? using only pi unit apart.
Okay.
Make sense?
Yeah.
So that's why I get right here, that will be what? Pi over 2 plus what? Not 2 pi n, it will be what? Pi n. That will include this solution as well. Are we
Got
okay
it.
now? But now, look at this. We are not talking about what? A single angle. We are talking about double angle. We are not talking about theta, right? So we are talking about what? 2x. So therefore, 2x is equal to this angle. And now we want to know what is x by itself. So I divide everything by what? 2. Are we all okay with this now? All right, so if you're okay with this, then continue on the second part, which is the second factor, 2 sine 2x minus 1. So solve for sine function. So that will be sine 2x is equal to half. So we already know that from the past examples, sine is half, right? The value of sine is half when the angle is what? In a quadrant 1 and quadrant 2. Because let's take a look at this. Let me draw it. In quadrant 1, there will be 1, 2, radical 3, right? That is sine is half, which is 30 degrees. And also sine is positive value on quadrant 2, which is 1, 2, negative radical 3. So this is also 30 degrees. So the first 30 degree in quadrant 1, the 30 degree is basically what? Pi over 6. Right? In quadrant 2, 30 degree, that is basically what? 30 degree less from 180 degrees, so it will be 5 pi over what? 6. But we can see that pi over 6 and then 5 pi over 6, they are not pi unit apart, not like this one. So I cannot just use one formula to indicate it. So I have to split it out into 2 different cases. So that's why I have this case right here. 2x is equal to pi over 6 plus 2 pi n. And another case, that is what? 2x is equal to 5 pi over 6 plus 2 pi n. Are we all okay with this? And then on the first case, if I divide both sides by 2, that will become pi over 12 plus pi n. And then I'm going to have to plug it in like n equal to 0, 1, 2, 3 like before. So when n is 0, that will be just pi over 12. When n is 1, and that become what? Pi over 12 plus pi, which will be 13 pi over 12. That is what? Basically outside of this interval that we are interested in. So therefore, this cannot be a part of our answer. Do we follow? And then similarly, on the second case, if I divide everything by 2, that will be 5 pi over 12 is plus pi n. And like before, I'm going to substitute 0. So when I substitute 0 for n, that will become 5 pi over 12. And when I substitute 1 for n, I get another answer, which is going to be 5 pi over 12 plus pi, which will be 17 pi over 12. Once again, this 17 pi over 12 is outside of our, domain that we are looking for. So therefore, this cannot be your critical numbers either. Any questions before I finish up this problem, concluding? So finally, after looking at all of this, my critical numbers will be, right? My critical numbers will be pi over 4, 3 pi over 4, pi over 12, and then 5 pi over 12. There's only 4 of them. Questions, difficulties before we move on? Are we good? All right. example E. So in example E, the function f is given to you that x minus 3 times square root of 9 minus x squared. And I already pointed out that my domain of this function is only between negative 3 and 3. Right? And the reason why is if you think about any value less than negative 3, then this x value will be bigger than 9, and then you will get a negative value inside the radical, which will become a complex number, which we don't know how to talk about complex number in calculus yet. We're barely starting calculus with real number. Right? So therefore my domain is basically what? Greater than negative 3. And also similarly, if I pick any number greater than 3, that will give me what? A complex number as well. So therefore it will be what? Between 3. For this problem, you can look at it and tell. Okay, if you cannot tell by looking at it, then you're gonna have to go from the very fundamental way that we learn. What is a domain? How to find out the domain of the radical functions? That will be what? The radicand is greater than or equal to 0, so therefore 9 minus x squared is greater than or equal to 0, and 3 minus x, and then 3 plus x greater than equal to 0. So that will give me my zeros are 3 and then negative 3, and I will have 3 interval to test it, and then from there on you will be able to find out which is the correct one. So this will give me negative, positive, and negative, which is this is the correct interval to satisfy this inequality. So those are basically a recall of what we did in pre-calc, right? To be able to find out algebraically. But if you see it right away, that's better, right? Some more complicated one you need to be able to do like this. So from now, we know that what is our function, a domain of the functions, right? Now we can start taking the derivatives of the functions so that we can talk about the critical number. So taking derivatives using the product rule, derivative of the first factor, and plus, right, times with the second factor, plus the first factor times derivative of the second factor. That's why you need to use the chain rule correctly. So square root is 1/2 power, so bring down 1/2, and it's minus one on the top, on the exponent, so it'll become negative 1/2. Now you take derivative of inside, that'll be derivative of 9 is 0, minus derivative of x squared is 2x. Now simplifying part, that's why I mentioned it before, in chapter 2, how far you need to simplify. Look at this kind of problem. The most simplest form that you can get, it will be easier for you to continue processing, meaning solving equations of derivative functions and so on and so forth, or even taking the second derivative later on in this chapter. So simplifying this, I can put negative exponent down here, and then I reduce 2 and 2, and then this minus and positive become minus right there. So I will get this format. And how do I go from here to here? I just basically combining these two fractions. So I need to have LCD. So the first fractions, I multiply top and bottom by square root of 9 minus x squared. So that will give me square root of 9 minus x squared, which will give me the square root of, square root will be gone, so 9 minus x squared. And simplifying that gives me negative 2x squared plus 3x plus 9. And this derivative functions, since the denominator is square root of 9 minus x squared, and we know that this derivative functions is also defined only on negative 3 to 3. Okay? Negative 3 to 3. So we know that the critical numbers happens on what? f prime of c is equal to 0. So that's always an easy part for you to find out. And this is always the part that you need to check carefully. F prime of c does not exist. So first up, derivative function equal to 0. When I set the derivative function is equal to 0, I can multiply both sides by denominator to clear the fractions, and multiply everything by negative to make it easier for us to factor, and which help us to get negative 3 over 2 and then 3. So we got two critical numbers already from this situations, right? Derivative function equal to 0. Now I have to think about when will the derivative functions is not defined, right? Does not exist. So we can see that this derivative functions does not exist on what? Negative 3 and 3. Because these two values are also a part of the domain. So therefore, my critical numbers are what? Negative 3 over 2, and 3. All of these numbers together. Questions? Difficulties?
Can you explain one more time why the negative 3 and 3 would be considered critical numbers?
Negative 3 and then 3?
Yeah.
Okay. So you can see that the idea of a critical number is basically what? According to definitions, that would be what? The function is what? Not the derivative of the function is equal to 0, right? Or derivative of the function is what? That's not defined, right? Does not exist. Are we all okay with this?
Yeah.
So after we take the derivatives, right? After we take the derivatives, and we can see that the derivatives will not, okay, exist, right? Derivatives cannot be defined, or derivative does not exist on what? Anything that is lower than negative infinity to negative 3 or 3 to positive infinity.
Right.
Follow? But however, this endpoint right here, 3 and negative 3, it happened to be a part of the domain.
Right.
So I can, technically I have to think about, instead of thinking about all of this, because of the domain is restricted, I only need to think about what? These value now.
Okay.
Because technically it should have been what? The f prime does not define on what? Anything that is less than negative 3 and anything that is greater than what? 3. Right?
Right. Okay.
All right. Any other questions before we move on? But later on, you will see that, when we talk about like local max and local minimum, those endpoints, you don't really use those. But the critical numbers, you have to think about those, because like we're going to talk about how to find out absolute maximum in a closed interval. So here's another functions, all right? But this time, what we are interested in is what? Find the extreme value of the function on the closed interval from 0 to 3. So let's review a little bit, or let's go back and then look at how to find out extreme values on a closed interval. What is the extreme value? We are talking about absolute maximum and absolute minimum. Okay. From the very first page of this sessions, we see that absolute maximum and absolute minimum can happen on the endpoints, or it can also happen on what? Critical numbers. So let's go back to all the way to the top page. On looking at this graph, notice that the absolute maximum or absolute minimum can happen on what? Any of those critical numbers, or at the endpoint also. Right? So for this particular picture, my absolute maximum is right here, one of the critical number, because that is the function value. This function value is the greatest among any function value in this interval. And also you can see that look, absolute minimum is in this endpoint right here, because this is the smallest function value. This is the only negative value that we have, right? I mean, not the only negative value, but the smallest function value right here. So that's why right here, this is what we need to remember. The closed interval methods of finding the extreme value. Right? So you can find out the absolute maximum and absolute minimum value of a continuous functions on a closed interval. That's very important. Maybe. And how do we find that? First, you need to find out the function value at critical numbers, and you need to find out the function value at the endpoints, and then compare them to see which one is the largest and which one is the smallest, so that we will be able to, identify absolute max and absolute min at which points, right? At where. Any questions before I go back to the example? All right. So looking at right here, okay, the extreme function value, right? Extreme value, that's basically talking about absolute maximum and absolute minimum. So first thing I need to do is I need to find out what is my critical numbers are. So taking derivative of the function, that gives me taking derivative of the numerator is 1 times the denominator, and then taking derivative of the denominator, right? Numerator times taking derivative of the denominator, that will give me 2x minus 1. Simplifying it, that gives me negative x squared plus 1 over x squared minus x plus 1 quantity squared. So because of this, derivative of the function is a rational, so we're going to have to consider the critical number can occur on f prime of c equal to 0, or f prime of c is what? That's not defined. Right? So first case is easy to determine. Setting the derivative function equal to 0, multiply both sides by the denominator to clear the fraction. So I got what? My x is plus or minus 1. But you are only taking x is equal to 1 as a critical number because negative 1 is not in the domain of the original functions that we want to look for. Are we all following so far? That's why in the beginning I keep on saying over and over again, you need to know, first you need to know how to find out the domain of the functions, just in case they want you to, look at it in the entire domain. So everybody okay with how I get rid of negative 1, right? From possible critical number. Okay. So if you understand this, then I'm going to continue to the next point, which is what? We need to check which x value will make this derivative functions does not exist. So that means basically I need to focus on my denominator part. Okay, will denominator ever be equal to 0? So x squared minus x plus 1, that is clearly is not factorable. So what I do is I use the discriminant to check what type of solution I will be getting. So that part you can do it mentally, right? So that you don't need to start from the scratch using quadratic formula and then finding out at the end, oh, that's a complex number. So when I check my discriminant, b squared, which is negative 1 squared, minus 4 times a times c. So when I simplify it, I got my discriminant value is negative, which indicate that, right? What is that? So which indicate that, okay, which indicate that this denominator will never become 0 with any real number. And that basically, you know, help me to conclude that this will never happen. Questions, difficulties before I move any further? All right, if you don't have questions, now after checking everything for the critical numbers, now I found out that my only critical number will be what? X is equal to 1. Okay, X is equal to 1. So according to this closed interval method, now I need to find out the function value at 1 and the function value at the endpoints. Okay, the function value at the endpoints. So when I find out the function value of the critical number and then at the endpoints, I found out that critical number is 1. And at the endpoints will be 0 and then 3 over 7. So therefore, right, at the critical number, it will be absolute maximum. And one of the endpoints give me absolute minimum. So now I can basically interpret it. The function is absolute maximum at x equal to 1, and the function is absolute minimum at x equal to 0. Remember, when you are testing it, you are testing to original function because absolute maximum and minimum is happening on the graph of the original functions. Okay. Any questions before I move any further from here? So, if you understood this, then the next problem will be basically the same thing, right? But with different functions. Again, this time we are interested in finding out the extreme value on the closed interval, the function g, and a closed interval of 0 and 8. So first, I'm going to take the derivatives of the g functions. And before that, and notice what I did right here, I simplify my functions a little bit by distributing this cube root of x into it. So that makes it easier for us, to take derivatives, and also avoid from product rule. So when I take derivative of this, that will become 8 over 3 x to the negative 2/3 power, and bring down the exponent, so 4 over 3 times x to the 1/3 power. Okay. So from there, simplifying it, right? So rewriting negative exponent to positive exponent, combining these two fractions together, which is I need to multiply by cube root of x squared on the second fraction, top and bottom. So that's how I got on the numerator will be just x right here. So from this, I'm gonna have to think about my critical numbers can happen on when it's equal to 0 and when it is not exists. And I have to think about this case because my derivative function is a rational function. So the easy case is always set it equal to derivative function equal to 0 and find out the critical number. So when I set it equal to 0 and multiply by LCD, so this will left with 8 minus 4x equal to 0. So that will give me x equal to 2. Since this 2 is in the domain of the the functions that we want to look at it, right, from between 0 and 8. So this is a critical number. Then the next thing that you need to look at is when does g prime of x, the derivative function, does not exist. Since the derivative function is a rational function, and in the denominator we have a cube root of x squared, derivative functions will not exist when x is equal to 0. So therefore, and also looking at it, this 0 is also a part of this domain of original function. So now I say that my critical number will be at 0 and what? 2. To find out the absolute maximum and absolute minimum, I need to find out the function value at those critical number and also the function values at the endpoints of the interval that we are looking for. So saying that I'm going to evaluate g at 0, I'm going to evaluate g at 2. So those are my critical number, and also 0 is at endpoint. And another endpoint is g of what? 8. Right? Function g evaluating at 8. So I will get, in this case, 0 on the g of 0, 0 on g of 8, and then when I substitute 2 for g function, it will give me 6 cube root of 2. So clearly, this is my absolute max, and then these two are absolute min. Okay? Since they are the same value, so we have 2 absolute minimum. So that's how I conclude it, right? We have absolute maximum at x equal to 2 and absolute minimum at x equal to 0 and what? 8. So this is a closed interval method for finding out the absolute maximum and minimum, okay? In a closed interval of a function, a given function. Any questions before I move any further?
There's only one thing I kind of don't understand is
Okay, go ahead.
prime of x does not exist on the right hand side.
Okay. Because when you look at the when you look at the g prime function, right? So g prime function will not be what? Defined at x equal to 0.
Oh, it's looking at that one. Okay.
Yeah. Right? What okay, what does it mean by derivative is it is differentiable and then it is differentiable. That means limits as h approaches to 0 of g of x plus h minus g of x over h, that is what? Equal to a limit. Agree? That's the definitions of the derivatives.
Yeah.
When the derivative does not exist, right? When it's not differentiable or the derivative function does not exist, that means we will not have this limit. So it means that it will be what? Either going to infinite case or the left-hand side limit and right-hand side limit is not the same.
Mm-hmm.
Make sense? And then we are talking about what? At any particular what? Point. Are we okay with that? So instead of using this definition, now that we have a formula, we can use the formula to get this limit in general a lot quicker. That's basically what exactly those two are. Right? So instead of like doing all of this, using the formula to take the derivatives, I can also go what? By this definitions right here. Are we okay with that? So by looking at this simplified derivative functions and talk about where this function defined or not, that can easily tells me where a function does not exist. Does that make sense? Are we all connecting and making sure that you see and understand that, right? So what we're basically talking about is what? If I put, instead of x, if I put 0 right here onto this function and using definition of derivatives, I will not have a value at all. I will not have a limit. So hopefully that helps you to see and connect with what we talked about before, okay?